Hey everyone, Christian Ludemann here, and welcome to this module called High Return of Investment Testing in Angular. Here's what we're going to cover. In this module, we're gonna first cover how I got to refine my take on testing and why you should follow this specific testing strategy to get the highest return of investment on your testing. I'll explain what this strategy is about. And we're going to dive into Playwright testing, how to do this strategy with Playwright, some best practices with Playwright, and then you're going to see a full demonstration on how to cover to-do app use cases with Playwright. So let's dive in. So the background for this module, a lot of Angular developers are experiencing testing problems. It's one of the most, I would say, areas of Angular development that are mostly disliked and that, is mostly confused what tools you should use and how you should do it in an efficient way. And it's one of those, especially for beginners, that they just end up spending a lot of time on without getting a lot of benefits back in return. So either they're spending a lot of time testing with little value in return, or they're just omitting testing altogether because maybe they have a tight deadline, they say they don't have time for it. And traditionally we've been taught about the testing pyramid and how unit tests should be the bedrock because they are the simplest to write. So that should be more than that's been like the conventional logic about it, but I'm going to cover how I see a different take on this. So let me take you back on some of my industry experience. So while working for a client building this platform for banking apps, it was scaling up to more than 50 developers and then like 100 people working on the same repository. And we had this 100% test coverage policy where we cover everything, and we ended up having 10,000 test cases, mainly with Jest. And these unit tests provided very little confidence in the use cases actually working. And we still had to overly rely on manual testing, and we rarely, the unit tests were rarely catching any real use case not working. It was just usually after doing refactoring or something like that, they'll just break tons of unit tests. And we found errors are usually found in the integration points. So we got very little benefit from all these unit tests, and we were looking for another strategy. Then, in parallel, this kind of paradigm was not only seen in Angular, but in the front-end world in general. So in the React world, which at the time was the biggest framework of them, there was this new testing approach going rival based on the tweet from Guillermo Rauch saying, "Write tests, not too many, most integration." And it's kind of like questioning this whole testing pyramid and saying you should focus more on the integration test because it has this perfect balance of convenience and effort to write the test and how much it takes to maintain it, and also the testing effort. Then the output you get, testing effort, is a lot better than having a unit test because you can cover full use case with an integration test, rather where a unit test would just be a separate unit. So at that time, our best tool was just to render the full route as a component with all dependencies. And so I started doing these kind of use case cover use cases with just integration tests, but they had some problem with async timing and JS DOM, which is not really as a real browser, and it required a lot of test setup, but it still gave more confidence with less effort. So now we have Playwright test that can overcome these problems and can retry the assertions and commands, so you don't need to worry about the actual timing with async. And it can run it in the same browser as the user, like a real Chrome browser, for example, which gives more confidence. because we're testing closer to the real user experience. So the same lessons learned from React, we started applying to Angular. So we started taking this can see dots approach where we have this testing trophy. That's can see dots debated on Guillermo Rauch. So just to be clear, who's invented this new movement. Yeah, the philosophy is like write few end-to-end smoke tests because they are very high effort to make and maintain, and they are flaky because they can break because of the backend and database data. But it's still good to have some like sanity smoke test that the app is actually working. And for example, just make it simpler. You can log in some simple test that just make sure you can do some basic non-modifying requests, so you don't need to worry about test data. That you can log in and you can see the main dashboard, for example. That would be the smoke test. Then the bedrock of your testing with this approach should be the integration test, which means you cover all the use cases. And here we use Playwright plus mock service breakup. We basically run Playwright against our app running in the mock environment. So we can control all the backend dependencies, all the networks requests are intercepted with mock service breakup. And this is what we're going to dive more into in this module, how to do this. And then we have we still have unit tests, and that you can use test, or you can use v-test. It's a little bit faster, and it's I see more common now to be used. So we can cover edge cases and calculations with unit test, and as well as shared code, because the Playwright integration test will be more focusing on sealing the use case logic, whereas if you have some shared, for example, UI component or some shared functionality or shared logic, then you want to cover that with a unit test. As well as when you then use it, then the use case you will be using it in will be covered with a Playwright mock test. And then you have, of course, you use TypeScript and ESLint, so we monomax that out. We use strict mode with ESLint. We use TypeScript. We type everything, especially like the backend responses, the backend contract is all typed out. We use, for example, open API generators to generate types, or we use something like TRBC, for example, to infer the types. Either way, we type everything out and don't use anywhere, because it's gonna pay positive returns to be covered in this way, and it's gonna save you from mistakes down the line if you make everything type safe. So getting started with Playwright testing. Let's look at the evolution of UI testing tools. So one of the first common one, at least in the Angular history, was Selenium, and Protractor was the Angular version of that. It provided us with unit testing. It had quite a big plugin community and stuff, which was nice. But it always had this flakiness. It was always this thing, it's super flaky, so we cannot really, so at scale it would always cause problems, because the more tests you have, the more the probability of a flaky test will just be higher, and then you just have a flaky test suite you will abandon in the end. So it was always a problem. Then Cypress came about, and it fixed a lot of these things. It fixed it by handling two things very well. It fixed the flakiness by retrying commands and assertions, like a user would. For example, when you go on a page, you naturally would wait a little bit for the spinner or the element you are looking for to appear before you disqualify the test and call it broken. So Cypress would do that, to have this retry until a certain timeout. And also the debugging experience was way better than Protractor, because you had this UI dashboard where you could see time travel step command for command what was actually going on, and it's easy to debug, and you can like have a video recording when it fails and all this. All very nice. And now where the industry is, it's Playwright is starting to become more recommended and more used because it's faster. So one thing with Cypress, it's running in the same browser execution context as the app. So it's just a bit slower in that way. So Playwright introduced better performance with parallelization and how to run it in a different way. And the browser support was better as well, as it was not relying on running in the same JavaScript context as Cypress. Also, that also allowed you to be more flexible with the programming languages you write your Playwright test in. So that's why we're focusing on Playwright and not Cypress with this module. So yeah, let's just go through the decision. What actually made me recommend Playwright now over using Cypress for so many years. I actually otherwise been quite happy with Cypress, especially coming from Selenium. So Cypress is running as a Node application using Chrome Developer Protocol to interact with, for example, the Chrome browser. And Cypress is this running inside of the app's JavaScript execution context, and that's how it controls the browser basically. So because Playwright is like running outside of the app, it's more flexible with using the different browsers protocols to control them, like Chrome Developer Protocol for Chromium browsers. Also has WebKit support with Playwright, and that later also got supported by Cypress, but it's a small browser support with the Playwright. One of the biggest selling points with Playwright is the parallel execution and the more isolated context. It makes it faster and more safe to run. Whereas Cypress was slower because it runs in the real browser tab, and you could do something with parallelization. It had this like paid option for a dashboard, but that required it to run in like some external paid thing. Most people, when you just install an npm package, you're not really up for just paying for some extra service for using it necessarily. Better like mobile support for emulation for iPhone, Android. It wasn't really officially supported by Cypress. You could just get some tools for it, but not out of the box. Multiple tabs is supported better with Playwright. Component testing for Playwright is supported for some frameworks, but not yet officially supported for Angular. I don't think it would be nice to have it as well. For example, component testing would be great if you had like some shared components of you want to cover. But the testing strategy we're mostly using for covering use cases in an app is just running the app in the mock environment. Because anyways, if you will do what I would do before was I was using, for example, Cypress and run it as a Cypress component test. But that would actually take just as long time as spin up the real app, because I'll mount the whole app in a component test, and then I'll do routing from there, which is basically just spinning up the whole app. So I could get rid of all this component test setup code with just running a Playwright test against the mock environment. So yeah, that's why I recommended this approach. Debugging, Cypress definitely from where we came before with Selenium had some nice debugging tools. But especially if you pay for the dashboard with Cypress, it can be nice for replay. But you have the same with Playwright now. You can even download this timeline of this replay file where you can, if it fails on your CI, not only can you get the videos for replay and the images of the failed page, but you can also get like a whole history. You can download from the CI when it fails, and then you can basically get the whole time travel thing where you can see like command for command if there's any errors in the app or what the app looked like at that point. So it's really, I would say Playwright has gotten even better for debugging than Cypress. Test isolation, it runs in per test browser context, whereas, as you know, Cypress is in the same browser execution context, which can cause some leakage. You see sometimes where one test can make other tests fail, so nice for Playwright is more isolated that way. You have parallel execution, for example, like native CI integration, and yeah, that parallel thing required the Cypress Cloud paid external setup. Language support is more bigger language support in Playwright because of how it runs like as a Node app outside of or whatever app. For JavaScript is a Node app, but it interacts with the browser protocols, whereas it's running in the JavaScript context. So it was only JavaScript and TypeScript for Cypress. And then the licensing is more free or open source with an MIT license, whereas Cypress got a bit more commercialized with the cloud features, which is behind a paywall. So that's why in the end now a lot of people choose Playwright. That's what I see in the industry right now, that people are favoring Playwright over Cypress. And that's why we are going to make the same decision here to go with Playwright as our main testing tool. So the setup, I recommend using NX for the setup. Of course, you can do it with Angular CLI as well, but I see more and more projects using NX because it has these benefits. Even if it's only a standalone NX application, you still have the caching, you still have the modularization of different libraries, module boundaries, all this good stuff. And you have the schematic for setting up playwrights in your app. So you can run this command and then it will add like a playwright testing to the specified project, which is pretty straightforward to set up. It doesn't get much more easy than that. And then it has like a basic setup, which is quite fine. Now let's cover the ideal way to write integration tests. So this is some best practices I recommend you keep in mind when you are writing Playwright tests. First of all, you should use the browsers that best represent your users. You can run Playwright in all kinds of different browsers, make it spin up in all kinds of different browsers. For the most part, I would actually just pick the main browser that your users are using. So that would normally be, if it's like very enterprisey app, so that'll normally be something like Edge, which is still Chromium now. Or if it's not, if it's mostly used by retail, then it will be Chrome probably. So I'll pick one of those browsers, just use that. Don't worry about spinning up 5 different browsers, because I think that's going to cause more confusion than actually benefit. Just if it works in the main browser, then that's probably how you get the biggest bang for the buck. Maybe in the smoke test, you can spin it up in all the different browsers if you want, but that's my 2 cents on the integration test, because there's going to be lots of them. Use page objects. I would also recommend it. Simplifies your tests. It makes it easier to change test frameworks later. I tried that a couple of times, for example, changing from Protractor to Cypress and Cypress to now Playwright. It just makes it a lot more easy because you can keep the same test logic. You can basically just need to rewrite what's inside of the page objects if you follow this pattern. I recommend you use mock service worker and mock scenarios because it's like a 2-in-1. You have both local environment. I think you should have that always. So you're not depending on the backend having released the newest features in the staging environment, or it could be that you are working on the app while you're sitting in a train or traveling and you have intermediate internet disruptions. So having a mock environment can allow you to test that, and also just so you have a consistent way of like reproducing certain error scenarios. For example, you can make sure that the right error state is shown given maybe a certain HTTP request is failing. You can do all this with mock service worker and this mock scenarios technique I'm going to cover here as well. Retry and error. I recommend you do at least one retry in Playwright, which is also going to be shown in the to-do monorepo repository. how to set that up, but it's basically built into Playwright. So it is setting you set up, and that's gonna, even if you had some kind of flakiness, that will make the test retry and give it one more go before it calls itself as failed. So we want these tests to run as stable as possible. Locate by role, and then fall back to locate by data, the test ID custom attribute, because locate by role is how a screen reader would locate things on the screen. It's more like natural, how a human would identify certain types of elements on a screen, rather than going for specific DOM attributes. And if you go with DOM attributes, go with the custom test ID selector. And then focus on the use cases. We use this Playwright to cover all the use cases against the mock environment. And that's how we're going to get the highest return of investment on your testing. So yeah, run the same browser as your users. Playwright support probably all the browsers and even emulated iPhone and Android. I would say pick the one that is the most used and representative as your users, and then stick to that. Just run that one browser. Maybe in the smoke test you can run more, but for the integration test, just pick the one that's, because you want the highest confidence and the less brittleness. Page objects. So this is an example of how I created these page objects used with Playwright. So page object would take this Playwright page object, basically wrapping. This is like the generic object in Playwright, allowing you to access these test commands like assertions and locators. So we see how locators, this is get by test ID and get by role, for example. So you see how you can do different things like that here. How to navigate, we will use that. We will fill out forms. We will do assertion with expect, and yeah, you can see then in the test here how simple we then can do the test. The test becomes very simple, and they become it becomes possible to basically change the testing framework very easy. So if you were to change it with, let's say, in 2 years or whatever, a new testing framework comes out, we could basically just copy all this code, and then inside of here we could change the locators to be the new fancy testing tool. So yeah, and also just very much more readable to write it like this. So I recommend you use a page object. So for each page next to the component, I would have this page file. So for example, to-do list page would be the page object next to the to-do list component. So you have this nice abstraction, more readable test logic, and easy to change test framework. So we do things the right way with abstractions. Then this mock setup I talked about. We create the mock setup with a tool called Mock Service Worker. You can just install it from your package manager. It's free to use. It's a mock environment. It's like a 2-in-1, because you get a local mock environment that you can use for local testing and easily reproduce any scenario locally with any, could be an error scenario, it could also be like a scenario, an alternative scenario you want to have covered. And it can also be used for testing, so you don't need a lot of testing setup logic, because you can just reuse whatever you have here. So that's really cool. It's gonna make, that's why there's not much. You see, there's not much code to write the test. Testing was before this thing that required lots of code and it was brittle and all this. Now it's just, it doesn't require much, and we can easier debug the test, because everything you can do in the test, we can get the app in the same state, just using the same mock scenarios, for example. So how we do this, this is in the main TS file. We load this worker.start, that's what we get from mock service worker. We have this handlers file that, it's we set up with the mock service worker when we define the worker. And that basically takes, first we create scenario handlers. We will cover that in a bit, how to set up mock scenarios, and then also these general handlers, which is like the success scenarios. And this is the scenarios are like the alternative scenarios. So for example, we will have like this regular expression when you hit go to request the URL that matches this regular expression, then we return this mock data here. And then yeah, we just set it here. So that's how we set all our different handlers in here, and then we have the mock scenarios. Yeah, this is the mock scenarios. So this is based on our default mock handlers, which is like our success handlers, like for example, where we return the list of to-do list items. Based on them, we can, for example, create a mock scenario for when the get requests to-do list items, for example, return a bad request. So that's what you see here. So we can create scenario and then return bad request. And you see like this is a helper. It's in the to-do app repo, so you can all just by searching for it, you can find it. You can just copy it from the slides. Yeah, how it will just take the path and method from the default handler. It's basing this mock scenario on, and then it can return some other scenario resolver. In this case, it's this bad requests. It's gonna make a return HTTP bad request response. And then we have this mock scenario file here that is, based on this key value pairs inside of local storage. It determines which mock scenarios are enabled. And then it matches these names here. For example, get to-do list bad request would be the key for the key value pairs of the mock scenario. And that's basically how you enable these mock scenarios. So that can be done both in your mock environment and also in your test. And I'll show you how to do that in your test, because with Playwright that requires you to access the app's JavaScript execution context to set the local storage. But you can do that with Playwright. So Playwright allows you to do that like you could in Cypress. But as default, it's just running through the browser protocols to control the browser. So here we see this is the GUI I made for mock scenarios. So I created this page that you can see here. I enable the mock scenarios for get to-do list bad request, and then we get an error here, as we should, with a 400 error, because that's the scenario enabled. And then I can see that it should show like a toast with an error here. So yeah, this would be very difficult to like consistently reproduce. You'd have to do something like disable the network, which or maybe the other ones we cannot. It's very hard to reproduce if you don't have like some scenarios like this where you can just enable a certain scenario. So it's really convenient that you had this, and all this otherwise would be all this test setup code. It's just built in here so you can test it locally and you have it available for your Playwright test. So I built this GUI because it's even like a tester can go in here and enable these scenarios with the GUI, and then they can assert that the app behaves as it should, basically.